So, welcome students to synthetic division, which is on page 10 of your notes. Remember page 9, which you probably skipped, are the optional notes, which if you want to do them, are due by the end of the 6 weeks. So now we're on page 10. So synthetic division. Synthetic division. That blank is really small, I apologize. Is a shortcut way to divide polynomials. So you already learned to add, subtract, and multiply. Now you're going to learn to divide. It only works if you're dividing by a linear binomial with a leading coefficient of 1. So that means something like x plus 3 is okay, but not this or not this. So it has to be basically x plus a number or x minus a number. It's the only times it'll work. If a binomial, so one of these, x plus something or x minus something, divides a polynomial without a remainder, so if the remainder equals 0, then the binomial is a factor of that polynomial. So if you remember way back when we did this together, we were learning about factors and how to find factors. This is another way to find factors. It was more useful back before these magic devices were so readily available, but it's not too difficult, so I don't think you guys are going to mind. So it's kind of like long division, which you might have learned in elementary school, except a lot easier. So I'm going to show you with this example. So given that f of x is 2x squared plus 5x minus 3, so we have 2x squared plus 5x minus 3, and g of x equals x plus 3, we're going to find this polynomial. We're going to divide. So we're taking 2x squared plus 5x minus 3 over x plus 3. So we set up the problem. Now here's how you set up the problem. It's kind of like a division sign, but upside down. And then you're going to take this right here, but write down the root that corresponds to this. So remember the previous notes. You had factors, and then you had the corresponding roots. So you had to flip that sign. So that's what we're going to do here. Instead of, I got my papers all messed up. The root that corresponds with this is x equals negative 3 because you have to flip the sign. So you're going to put a negative 3 right here. And then here you're going to imagine you have 2 rows. You normally won't put a line there, but I'm putting one just for now to show you what I'm talking about. Imagine you have 2 rows here, and you're going to list your coefficients on the top and leave some space underneath them because you have to write something else. And you don't really have to put this much space. I'm just trying to make it big and easy to read. Okay, so we set up the problem. Yay, done. Step 2, carry down the leading coefficient. So that's this. The leading coefficient is the first one. So carry it down and just write it down again. Multiply the leading coefficient by negative 3, which is here, then put it under the 5. So you're always going to take this number times whatever you just wrote. So negative 3 times 2 is negative 6. And you're going to write it in the next spot. Then you're going to add down the column. So 5 plus negative 6 is negative 1. Yay, step 3 finished. So then multiply by negative 3 again. So whatever you just wrote down, you're going to multiply it by this. So negative 3 times negative 1 is positive 3. Put that in the next available spot. And then add down. Negative 3 plus 3 is 0. And then if there's more coefficients to go here, then you just keep going. But we're done. We don't have anything left to divide. So we're done. This right here, the number on the bottom right is your remainder. So this number is our remainder. When the remainder equals 0, which ours does, so it equals 0, that means x plus 3 is a factor. So if the remainder is 0, then whatever you were checking is a factor. Yay! If the remainder weren't 0, then whatever you were checking isn't a factor. Boo. So now what you have is, let's go ahead and write the whole problem. 2x squared plus 5x minus 3 over x plus 3. Your actual answer here is not just that that's a factor, but your answer is actually right here. Circle it in a different color. And it's kind of like doing a matrix. You have the coefficients, now you just have to put it all back together. So you're going to start with a 2, and then x2, and then go 1 power lower than this. So it's x to the power of 1, and then minus 1. So that right there is your answer. That means we can check our work like this. Set up your box. Yes, more box method. And take the one we tested times our answer. And make sure we get this again. So 2x squared, 6x, x, negative 3, which gives us 2x squared. These two like terms come out to 5x minus 3. And it does work. So yay, we got it. So that's synthetic division all the way through, including checking your work. So let's try another one. So example 1. We're going to go ahead and divide this and see what we get. So set it up. Remember to put the root right here, so flip the sign on this. So it's x minus 1, so I'm going to put a positive 1. And then put your coefficients at the top. Remember to leave space underneath. Don't need it to be that long. And then follow your steps that are up here. So the first thing I want to do is carry down the leading coefficient. Then I'm going to multiply. 1 times 1 is 1. Put that here. Then add down. 5 plus 1 is 6. Then whatever you just wrote, multiply it by this. 1 times 6 is 6. Write that in the next spot. And then add down. 6 plus 6 is 12. Now, since my remainder does not equal 0, this is not a factor. So my remainder is not equal 0, so this is not a factor. X minus 1 is not a factor of this, which some of you may have realized already from this negative sign here. There's no way that that's going to factor into that. So there's no need to check my work with box method because it's not going to work. But you can still write out your answer. So here's how you do the answer. Again, start with your coefficient 1, x, and always go 1 down on your exponent. So instead of an x squared, it's going to be an x. And then plus 6. And then when your remainder is not 0, you just put the remainder over the same denominator. And that's your answer right there. So 1x plus 6 plus 12 over x minus 1. Okay, well, let's try another one. And remember, once you reach the end, that number is your remainder. So my remainder equals 0. This is a factor. So let me write down the answer. So check my work with box method. So check. Here's my work checking it, and it does come out to our original polynomial. So we figured out that x plus 4 is a factor, and we figured out that when we divide it away, it's going to leave us with 2x squared minus x minus 2, and there's my work to check it. So I'm going to let you guys try example 3 right now, and then continue the video to check and make sure you did it right. So here's what you should have gotten. You got a remainder that is not 0, so this is not a factor. And you write out your answer as 3x squared minus 8x plus 12 minus 10 over x plus 1. So you figured out it's not a factor. No need to check it with box method if it's not a factor. Now we're going to do example 4 together just because since some of the powers are missing, it's easy to make a mistake if you've never done one like that before. So let's set it up. -1. Now notice I've got an x to the 5th, but x to the 4th, 3rd squared, and x are all missing, which means I need to put zeros for all of those. So -1x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then 1. So you should have 4 zeros in there. And now we're ready to divide. So bring down the leading coefficient, -1. Multiply, put in your next spot, add down. Multiply, write it in the next spot, add down. Multiply, write it in the next spot, add down. Multiply, write it in the next spot, add down. And finally multiply, write it in the next spot, add down. Now, check out that exponent. Do you think that x plus 1 is a factor of negative x to the 5th plus 1? Good, so you should have gotten, no, the remainder is not equal to 0, so this is not a factor. Therefore, you do not have to check it with box method. Go ahead and write down what the quotient is, though. I'm going to write it down here because there's no room up there. So you should have picked x to the 4th plus x to the 3rd minus x squared plus x minus 1 plus 2 over x plus 1. Remember, you always start with one exponent lower than your original polynomial.